Hello. Today we are going to talk about how to use the distance and the midpoint formula. And so basically we're just going to start off with talking about like what these things mean. So if I have 2 points on a coordinate grid, like say for example, this point here and maybe like this point here. I might want to find the distance between those 2 points. When I talk about distance, I'm talking about like a straight line distance. So if I were to walk from point A to point B, how far would I walk? And so first thing you need is the coordinates of each point. So for example, this one here is the point -5, 7. And this one down here is the point 4, 1. And so I want to know if I'm going to walk from the point -5, 7 to 4, 1, how far would I travel? And just like we've talked about multiple times when you have like slope and things like that, each point is written as a coordinate pair x, y. And we'll call one of these points point 1. So therefore, x1 is -5, y1 is 7. And we'll call the other point point 2. So x2 is 4 and y2 is 1. And then we're going to use those, x1, y1, x2, y2 to plug into the distance formula, which is right here. All right, so let's do some example problems together. So if I want to find the distance between the points -1, 4 and -1, 10, first I would identify which I'm going to call point 1 and which point 2. So let me call this one point 1. So that's x1, y1, and I'll call this one point 2. So that makes this x2, y2. If I were to just plot these points real fast, this is the point -1, 4. So this is point 1, and then -1, 10 is up here. This is point 2, right? And so if I plug in to the formula, it tells me the distance is going to be equal to the big square root of x2 minus x1. So x2 is -1 minus x1 is -1 squared. And like always, minus a negative becomes plus a positive. And then y2 is going to be 10 minus y1, which is 4 squared. So let me simplify some of this stuff. So -1 plus 1 is really 0. And then 10 minus 4 is 6. So my distance is going to be 0 squared, which is 0, plus 6 squared is 36. 0 plus 36 is 36. So the square root of 36 is a perfect square because 6 times 6 is 36. So the distance between those 2 points is 6 units. And if I look at my graph over here, if I were to walk from point 1 to point 2, it's straight in a vertical line, so I can go up 1, 2, 3, 4, 5, 6 units. All right, but here's the thing. It's not always going to be a nice whole number because sometimes the points are not going to be just in a straight up vertical or horizontal position from each other. So here, let's do another example problem. We'll call this point 1 and point 2, and we'll plot the 2 points. So the point 3, -1 is right here. And the point -4, -6 is right here. So this is 1, this is 2. When I walk from point 1 to point 2, I'm not walking straight like horizontal or vertical. So how do I know exactly how far I'm going? I can't just count, grid marks like I did in the previous problem. So let's plug in. Let's see what happens. So x2, -4, minus x1 is 3 squared, plus y2 is -6, minus -1 squared, and minus a negative becomes plus a positive, right? So -4 minus 3 is -7 squared, plus negative 6 plus 1 is negative 5 squared. So negative 7 squared means negative 7 times negative 7, which is going to be a positive 49, right? And then, again, negative 5 squared is negative 5 times negative 5, so it's positive 25. When I add these two together under the square root, I get 74. So I'm looking for the square root of 74. Now, 74 is not a perfect square, so I'm going to have to look and see if I can simplify that. So I have to make a factor tree. What goes into 74? Well, I know it's even. So if I use my calculator and I do 74 divided by 2, I get 37. But then from there, 37, nothing goes into 37. So that means I can't factor this any further, and that means I can't simplify the square root of 74 anymore. So the distance between 0.1 and 0.2 is the square root of 74. You can leave your answer like that, but if you plug into your calculator and type in the square root of 74, the decimal you get is approximately 8.6 units. So it's, in other words, it's saying if I were to walk from 0.1 to 0.2, I would walk about like 8.6 units, or like the distance, where a unit is the distance between these grid marks. I'm just walking in a diagonal line. All right, here's one more that I want you to try. So you can pause the video right now, try it on your own, and then unpause and come back and check your work. All right, so now that you've done that practice problem, take a second, check your work. And again, visually, if I were to plot these 2 points, the 0.2 comma 1 and the 0.6 comma 4, it's saying the distance between points 1 and 2 is 5 units. All right, so that's distance. Now let's talk about what if I'm trying to find a midpoint. So instead of finding the distance between 2 points, if I want to plot the 2 points, so for example, negative 1 comma 4, so negative 1 comma 4 is right here, and the point negative 1 comma 10, same ones we had before. And if I were to think of these as like a line connecting those two, where is the exact middle of that line? Or in other words, where's the midpoint? Well, we know in example 1 previously that the distance between the two is 6 units, right? 1, 2, 3, 4, 5, 6. So the middle of that would be 3 units from either side. So right here, this would be the midpoint. And if I were to look, this is the point negative 1 comma 1, 2, 3, 4, 5, 6, 7. So this is the point negative 1 comma 7. That's easy enough to do when the 2 points are exactly horizontal or exactly vertical from one another. But again, if they're on a diagonal, it gets a little trickier. So we have what's called the midpoint formula. It's right up here. And basically what you're doing to find the midpoint, you're trying to find the middle. So you're basically taking the x values and averaging them. You can see in the formula here, you're taking the 2x values, adding them up, and dividing by 2. That's just finding the average or the mean of the x's. And then you're doing the same with the y's. And then I'll erase this so you can actually see it. But it's written as a point. So your final answer is going to be a point, x comma y, right? All right. So even though we could tell that this midpoint is going to be the point negative 1 comma 7, let's use the formula to show algebraically how we got it. We'll call this x1, y1, x2, y2, and it doesn't matter which point you call which. And then if we plug in, the midpoint is going to be x1 plus x2. So x1 is negative 1, x2 is negative 1 as well. So negative 1 plus negative 1 divided by 2, comma, y1 is 4, y2 is 10, so 4 plus 10 divided by 2. Now we're just going to add. Negative 1 plus negative 1 is negative 2 divided by 2. 4 plus 10 14 divided by 2. And now I'm going to simplify. Negative 2 divided by 2 is negative 1. 14 divided by 2 is 7. So we get the point negative 1 comma 7. It's like magic. So algebraically, you're just taking the average of the x's and the average of the y's. All right, let's try another example. So if I have the points 2 comma negative 2, so 2 comma negative 2, we'll call that point 1. And then 5 comma negative 6, we'll call this point 2. And if I were to draw the line connecting these 2 points and find the midpoint or the middle, it looks like it's like maybe somewhere right there, right? That doesn't land on like the grid marks. So it's not as easy as the one I just did previously. So I'm going to use the formula. Call this x1, y1, x2, y2, and we're going to plug in. So the midpoint is x1 plus x2. So 2 plus 5 over 2, comma, y1 plus y2. So y1 is negative 2 plus negative 6 over 2. And then I'm going to simplify. So 2 plus 5 is 7 over 2. And then negative 2 minus 6 is negative 8 over 2. And then I can see if I can simplify this anymore. 7 over 2, I can't reduce it or anything. So I'm going to leave it as a fraction, 7 over 2. But negative 8 over 2 is the number negative 4. So this should be, the midpoint should be the point 7 over 2 comma negative 4. Now, if I look at this point that I just drew, this red point, I'm off a little. It should probably be like more here, but a little bit lower here. But you can see 7 over 2 as a decimal is 3.5. So like 1, 2, 3.5. So the midpoint, let's draw it exactly. That would be more helpful. So if these are my original 2 points, the midpoint would be 3.5, so 1, 2, 3.5, comma negative 4. So it would be right there. And if I look, it looks like it's smack dab in the middle when I would connect those 2 points. So that's how you find your midpoint.